So 14.44, here's the question. It says that the balance wheel of a watch vibrates with an angular amplitude theta, angular frequency, and phase angle of 0. Find expression for the angular velocity and angular acceleration as functions of time. And then B, find the angular velocity and angular acceleration when its angular displacement is theta. And when its angular displacement is theta over 2 and theta is decreasing. So, let me see. For A, I have that theta of t equals theta cosine angular of t, and then I have that the derivative d theta in respect to t, which is the angular velocity of time, given by this, equals w theta sine w of t. Oh my goodness gracious. One second. So, and then I take the second derivative, which is going to give me angular acceleration of time. And that will equal, it's denoted by this, and that's negative angular squared theta cosine w of t. And then, let's see, for B, let me erase all of this. So for B, I have that theta equals theta cosine w of t. And then 1 equals cosine wt, and then wt equals 0. And then I have, since it equals 1, we can say that sine squared w of t plus cosine squared wt equals 1 minus cosine squared w of t, just using some properties that we know. So let me write that down. So sine squared w of t plus cosine squared w of t equals 1 minus cosine squared w of t. And then this equals 0. So w of t equals 0, and a of t equals negative w squared theta. And then for at theta halves, I just plug it into the equation. So that's a 1/2. Equals cosine wt. So w of t equals pi thirds. Woo! And since sine squared of wt equals 3/4, we can conclude that w of t equals negative w theta root 3/4. So w of t equals negative angular times theta times root 3/4. And then we conclude from part A that a of t is equal to negative 1/2 w squared, negative 1/2 angular squared theta. Therefore, as theta increases, cosine of WT decreases.